glad to have you here. Especially glad to have Johannes here. Johannes is leading. Can you bring up the slide? Du bist da. Okay. He's leading AI at Hexagon, and today he talks about a very interesting topic. It's about reality capturing, or in other words, creating digital twins. Johannes, thanks for being here. The stage is yours.
Thank you. Good afternoon, everyone. Hello, and welcome to the talk about reality capture and AI. In case you were wondering what this is all about, what we do at Hexagon Digital Twins. So what you saw is the digital twin of the Zurich city. And welcome to my talk about reality capture, AI, and how we make use of data in our business, primarily in what we've learned in the past 12 years of that journey. First, let's start with the basics. What does Hexagon do? Hexagon is a global leader in reality technologies. We basically build sensors, the software next to it, and ship that to our customers so that they can make use of that data to the best extent in the various industries. We're quite broad. Then you may want to ask, when you saw the title, what is reality capture? I've seen a couple of analogies today, soccer, carrots. Let's stay with dogs for this one. So the analogy that I'm using is a dog, particularly our devices measure the 3D world as we see and feel it as well. We start with individual points. For the data scientists, we basically take a laser, measure it, have a horizontal and a vertical coordinate, including the distance, so we get a vector. We do that in an incredible speed, some sensors up to 2 million points per second. So we get very high fidelity understanding of the 3D space. We then convert that into our mesh models. Some call it a soup of polygons. And then ultimately where machine learning and deep learning help us is actually bringing semantics into the soup of polygons so that for every point and mesh part, we know whether it's part of the left ear, of the left leg, right leg, etc. We do that with in-house made sensors that we produce, develop, and ship ourselves, some of which are very portable, that you can take yourself and just, for instance, scan the circle as you could see it here. Others, if it's prohibitive, dangerous to walk through, we have carrier platforms such as Spot, what you can see here, or Unitree, or Animal, or whatnot. And then others are for the traditional surveyor's world, such as the RTC 360. Two examples with the scanners. The accuracy of the, when we talk about accuracy, you have here a coin that's 1 Swiss franc. If someone would be in Oerlikon at the train station, roughly 5 kilometers line of sight, we can still decide whether we would like to point at the upper or the lower half of the coin. This is what we call accuracy. And speed is maybe a second example for the RTC 360. 2 million points per second measures up to 120 meters. Why? Because the light is not fast enough to get back in time. This is the second thing. So it's all about 3D information, but it's a quarter of what Hexagon does. The other 3 quadrants you can see here, we start with reality capture, sensing the real world, bring it into a digital twin, then provide, manipulate, change, update, etc., and then bring it back via our location and positioning intelligence services into the real world. And it's neither left or right, it's the interplay between those two, and that's heavily data-driven. Hexagon is a public company, 24,000 employees, 5.4 billion in revenue, and for the financial guys, 29% EBIT, and we are structured into 5 individual companies under the brand of Hexagon. We have one central organization that's called the Innovation Hub, where we provide core technologies to the group. Those core technologies you can see here. Those are super important that we can keep providing innovation across the individual business teams. This is visual computing, UX, UI, industrial designs, robotics, and on the top left is the artificial intelligence part, which I'm responsible for. And the way it's perceived, it's really for us data insights and business cases to drive and scale and make our products better. Why is that important? Well, there is nice innovations that come out, which also get one or the other award, such as our BLK to fly. So if I would like to measure the roof of this building, I don't need to go up there, I can just fly. Again, in-house developed, in-house production. But we don't do that only with the BLK series. So from the more general and democratized version for high-end scanning, underground, mobile mapping, as well as airborne based. So the model of Zurich, you have seen that was an airborne camera which flew over the city of Zurich. So in case you ever wonder that on 20 minutes is an article, why did a plane fly in a meander over a city? Probably us. Because we measure in 3,000 meters altitude about 12 points per square meter and then use that digital twin for further purposes. And this is how it would look like in the example of Munich. What you see here is a digital city twin that we produced. We basically flew over Munich, captured the data, and the reason why it looks so super realistic is because we understand what's behind each individual point where it belongs to. And we combine that with our on-the-ground data that we scan with mobile mapping information so that you get the utmost resolution on things that don't move. Because we also, with AI, can understand what moves and basically remove it because it will be just clutter. And this is at the end where we're in a somewhat good position because there is a lot of data. We have a few other challenges with that, but I'll get to those. What do I mean with what is behind there? Here is an example from New York Central Park. Well, below the texturization are semantics. Here you see what is a building, man-made structure, so to say, is what we classify it. And also, once I saw some people, they used satellite data and said, we can count the trees. Well, good. We can tell you how large they are, where they are exactly, and we can also measure the trunk as well as the canopy size and the volume because we have the full 3D information ourselves. This helps for urban planning in cities, revitalization, and other examples. This is what we present to the public. Today I'll show you a bit the world, what our teams work in, which is, I personally find it super exciting. This is Stuttgart. We basically drove through Stuttgart, and here you can see the point cloud, and this is the masking in individual objects, what we can derive. Fully automated, no humans somewhere. Buildings, cars, lawn, vegetation, curbs. Why is that important? Well, cities have a high interest to know where their routes are, where the traffic signs are. How many street poles do I have? How tall are they? What are the markings on the road? Are they complying with different legislations that you see here? You may want to find it funny, but no city knows exactly how many street signs they have out there because it would take time for people to go out. With us, we drive with our mapping systems through that, run it through a processing pipeline, and give them a very more than 97% accurate result of their inventory. And the rest ones we usually also then do some human correction at the end. I hope that gave you a bit of an idea what we do. You can see here a couple of combinations, and this is where we excel. The combination is always from the sensor up to the final application, whether that is, as you can see on the top left, the mobile mapping for construction, finding pipes underground or indoor modeling. Since we are in Zurich, we also do a bit more than 3D information for industrial facilities, especially extending digital twins with documents. On the top right, our public safety systems, and if you ask yourself, what is that? Computer-aided dispatching. So if you call the emergency hotline, someone picks up the phone, and what they look at is Hexagon software. Here, it's the Capo Zürich, Rega, Grenzfachkorps, Capo Tessin, Basel-Stadt, Basel-Land, St. Gallen, both Appenzell, and so on. We're quite a hidden champion. I hope you never deal with that, because that means you have an emergency. But rest assured, it's quite nice. Good. How do these solutions actually get to market? Not necessarily from the team that we have. What we deal with is applied research, development, deployment, and enablement of AI. But basically, we understand the use case together with them, and then we provide the models to the application, because compute has to be where the data is. That is important. Also, depending on whether it's a desktop publishing software, a cloud-based solution, or the likes, centrally in Hexagon, managing such an environment does not work. It is the exact opposite to some others. I think, to what I hear today, very similar to the Migros Group, which is also 5 independent businesses. But the beauty is, you work on very different industries doing the same thing. And the same thing in terms of data and applications for us means those 6 areas. Where you see, those are focus areas on a group level, and in particular in my organization, which we identified. From the very left, from universal applicability, text, voice, to documents, still very broad. For us, always in an industrial context. It's never an insurance claim, but this is P&IDs, floor plans, inspection manuals, checklists, operator rounds, handover documents, safety procedures, with COVID, hygiene procedure checklists, etc. Then we talk about scenes. Here it's always funny, we used to say we play with only 2 things, time and weather. And that is helping to extend kind of certain cases, creating from one scene a different scene for training purposes, etc. I think the scan part I tried to convey, I hope that came across. But here the beauty comes as well with Hexagon as we build our devices. These are super unique areas that you can see, which are devices, ML at the edge, and sensors. The sensors are subcomponents of these devices, such as camera systems, IMU systems, and the like. This is a completely different domain here than what you have on the left, but all of which are equally distributed across the group. Now you think, okay, what do I do with the 500 people that I lead? No, there's not so many. This is quite effectively set up in that place. I will elaborate a bit on the history and how we are organized. First of all, what you can see here, we operate in a hub-spoke model. The hub, so to say, is the AI hub, what we have centrally, where we work on those focus areas. And the industry-specific AI teams are around it. So those are business teams, which usually have 1 or 2 data scientists at most. Why? Because in the lifetime of development, you have difficult times to employ a 10 data science team if you work on industry applications. It varies, but that's usually where we currently operate. What is important is that the interplay works quite nice. The interplay, as you can see here in the gray area, is composed out of 2 things. There is a top-down approach, which are lighthouse projects, budgets, priorities, who do we serve? And there is the equivalent bottom-up approach, where we have an AI community in Hexagon. Once a month, we meet on a regular basis. It's roughly about 150 data scientists across the group who regularly exchange. That doesn't mean they work together, but they have a regular exchange. There is a community, and many ideas came up this way as that way. Is it easy? No, it's super complex, because there is never one thing that fits all the time. Not every of these organizations works the same. Hexagon has a private equity background. As an idea, in the last 20 years, acquired 140 companies, 7 a year. So that means you have some companies which are, from the Bay Area, which are from north of the US, from Canada, from India, Australia, super different cultures, and so on. So this is something that is never solved. At the end, we started with 2012 with an ETH project on a central team with research. That took quite a while around the point cloud space so that it was picked up. In 2017 was the first product release with a deep learning model for mobile mapping, kind of the Street View cars. And then over time, we acquired very niche-specific companies that do good things with AI in a particular business area. And those is what we call the spokes. And you need to have them because they're super close to their customers. They're extremely close to the use cases. Otherwise, you will not get them back. But if you need to have larger projects where in a P&L and EBIT-focused organization, it wouldn't make sense to have a temporary workload or build up know-how, then we do it jointly together in a hub-spoke combination. And now we transition towards an AI-enabled company. One thing that you may ask, well, how do we judge these use cases? Which one should we do in a hub, in a spoke, should we do in the first place? It's kind of 3 dimensions. I know this is generic, but I can tell you it's always unique from a case-by-case scenarios, but it's 3 things. Usability or desirability. Does this provide value in the workflow, in the process? And that doesn't mean me having an idea, drafting something. No, really talk which mouse clicks need to be done, what is accelerated. Are you competing against the current status quo or not? Secondly, viability. Does it help the business? Do we earn more than we spend? Sounds simple, again, needs to be part of the business plan. And the 3rd dimension only then is feasibility. Can we actually do it in the particular case, desktop, device, cloud? There is a bit of a fine-grained example. What we usually use is a bit of a simple model, but it helps tremendously. Whether you ship something out, we usually talk genuinely about CTO cases where we are very strong, I would say. We help bringing revenue forward by quicker cycles, retraining instead of redeployment, or feature differentiation and increasing the win rate. Those go into products and are sold, whereas on the lower end, reduce expenses, increase throughput. This is now the wave that we can see with the whole thing about generative AI. We have done a set of pilots since last year in summer, and now our current task at hand is kind of how do we scale it across our 5 different divisions and their sub-teams. Again, different challenge because of the structure, but it works quite nice because we have a lot of people who want it, who see it. What are some of the lessons learned? On the top right, I think what we learned is starting central and failing is really, in hindsight, was good. Not always easy, because at the end you're seen as a cash burner as well. Those are confrontations that you need to just be able to argument through. Secondly, domain expertise is key. Domain expertise means that you have small teams very close to their customers, understanding the data, the implications. Without them, a hub team doesn't make a lot of sense, at least in our environment. The 3rd one, which we have seen in the last 3 years, is make versus enable. So do we actually train the model and ship it, or do we help people training it themselves and keeping it in the business line? This is a bit more effort, but if you talk about nowadays, we can help you doing it yourself, then people actually strive. Some of them strive to do so because it's an interesting field. Now, of course, it's a hype. The 4th one and the last one is be open and choose thy partner. Partners are important here. Technology partnerships such as Microsoft and NVIDIA, where we get components and then bring them into products. If you talk about capabilities, universities, here in Switzerland a lot. And if it is about CNPC, its innovation or such as its environment, such as the Data Innovation Alliance. I think it's never the question which one, it's rather than what's the balance between those and what do you need currently on hand. With that, here was a glance into the world of Hexagon and the 3D information. Thank you, and I'm very open for questions.
I'm just professionally curious. Your biggest data management problems?
Size.
How big?
Peta. Plural. But in one platform, that is, I would say one of them, where at the same time, sometimes none, because it's areas where we are not allowed to touch it because it's a mine, it's defense and so on. But kind of Yeah, those are the two extremes, I would say. Yet still we need to solve the problem for some reason.
Yeah, thanks a lot. Amazing stuff. What do you think? So you mentioned NVIDIA. How close or far away or in front of their Omniverse are you? So do you like that? Will this NVIDIA Omniverse help a lot with your stuff? Is it a
that's a good question. So
concurrence or yeah?
Yes, last year in June we announced a partnership with them. In March we released the detailed statement. So we're using Omniverse to extend, kind of capture the reality, and Omniverse gives the ability to simulate it. Practical example, you take a manufacturing floor, we scan it, remove the inlays, and then other companies can place production lines and simulate how they operate before they build them. We work with them. They're far away, location-wise, but we have quite a couple of people from them helping us. It's quite nice. Crazy, but nice.
Thanks. And another thing, maybe because of a hobby of mine, how much do you use VR headsets, and which ones are you using, if at all?
Well, we in the company, to some extent, on our customer basis, there is a pickup, but it is still very little. In an on an oil rig, nobody walks around with such a glass. On a construction site, likewise, it takes time. We know we have tools, etc., around, but from our customer base, we don't see a big pickup.
Thanks.
Thank you for the talk. I'm asking myself, what are the potential use cases of large language models in digital twins? For example, in the things that you show the city and of Zurich, and is there any potential cases that you can more detailed elaborate?
Yeah.
Thanks.
We have touched the tip of the iceberg, but with things such as Clip, where you have image language embeddings, we have the images next to the point clouds. It's perceivably a lot of possibilities. At the same time, not everyone has 2 Blackwells at home who process all of this from NVIDIA. We look at it, we do some research projects here with ETH and in Munich. NVIDIA, of course, publishes a few of them. They help us in that space. I think it will still take some time until it hits customers. Laptops, phones, what you have in the field, the amount of computer. Not everyone wants to work with the cloud. But I mean, the opportunities are quite broad, to be honest. Yeah.
Thank you very much for the talk. It is very interesting to see all the digital twins of Hexagon. And I know that recently Hexagon also has the digital twin of human face. Yeah, so could you please tell us about where the human face and the aesthetics industry is in terms of the big picture?
The big picture, so they're not accustomed with 3D information and with the know-how, whether we scan a city, a building, a mechanical part. We also recently released something that lets you scan a face in 3D and exactly assess whether or not any treatments have happened. Quite interesting. We didn't do it because we wanted to enter this industry necessarily because we thought it would be nice, but we saw that all the core competences in the Innovation Hub could be packaged into something. The team was small, agile, but they had decades of research that they could just use and import and use and do. Yeah.
Thank you.
Johannes, thanks so much for an amazing talk. Thanks everyone for participating. We have one last talk coming up, Michel Neuhaus from UBS in 10 minutes. Thanks so much.
Everyone.